This video is to help you with your write-up for Tutorial 4. In Tutorial 4, we were introduced to continuous data for the first time. In this data set on Academy Award winners, only the outcome variable age is continuous. Before we start breaking up the data by predictor variables, let's just look at the distribution of all the ages across the whole group. In the tutorial, we learned how to make a histogram using Google Docs instead of Excel. Before I put this into a write-up, I want to check my axis labels and the scales that I'm using. So on the y-axis, because this is a histogram, it's always going to be frequency. That is the number of data points, items, or in this case, people who fall into each bin. The bins along the x-axis are made up of age in years. I've chosen to use 5-year increments for the bins because it's easy for us to think about age in that way, and it also reveals some nice details of our distribution. Normally, if I wanted to put a graph into a write-up in Word, I would just select it, hit copy, and then paste it in. But Google Docs and Word don't play very nicely together. So if I wanted to put that into Word, I would need to click on this drop-down menu, hit Save Image. That would create a file that's just of this chart image, and then I could open it, copy, and paste that into Word. But I'm actually going to put my write-up into another Google Doc. We've been using one that looks like Excel. They also have one that looks like Word. So you click on this, and it will create something similar, not exactly the same, to Word. The nice thing about Google Docs is that it's saving all the time, so I'm less likely to lose my work. I'm just going to name this write-up 4. Now that I'm using Google Docs for my write-up, I can go ahead and select, copy, and I'm going to paste that in here. So what do we see? Well, I noticed first of all that it's clustered sort of around middle age here. So let's comment on that. Most actors and actresses win the award between, what's this, the bars really sharply go up here, 25 and 50. So between 25 and 50 years old. I want to tell my reader exactly what graph or figure to look at. So I'm going to tell them see figure 1. And then underneath that, I'm going to give my figure a label that corresponds to that. So figure 1. I also want to comment on the shape of the distribution. We don't quite have a symmetrical up and down distribution. There are a handful of people over here at the end, so let's comment on that as well. There are only a few people who win, is that above 70? So you can see that right here, 70. So what kind of skew would this be? Remember, we want to talk about which way the outliers are pointing, which way it's dragging the mean. So that would be a positive skew. This is a positive skew of the data. And you can see up here, it's saving as I work, and that's really nice. Now we can ask ourselves, is this all one single group of people that make up this shape? Or are there 2 or more groups in there that have different shapes? We can try to answer that by breaking up the data by some predictor variables. In this data set, we also have the categorical variable of gender to consider for each winner. We've done that. We have a histogram that is just representing the age at award for all of the actors only, and one for all of the actresses only. So let's make the scales of each axis the same in both the graphs. We'll need the x-axis to go all the way from the minimum to the maximum, so let's change this one to also go from 20 to 85. Do that here in Advanced Edit. Make sure I'm editing my horizontal axis. I'm going to change this to 20 and this to 85. Update that. We would also like to be able to compare the heights. So let's change the x-axis of this one to be, well, this one actually, let's just move it down to 25 as well. Here I need to change to the left vertical axis. Let's make the max 25. That'll make it easy to compare both the height and also where they are along the distribution of age. Let's also change the colors. All of the bars should be the same within one graph because this is all the same. These are all the age of actors, and these are all the age of actresses. But I'm going to make it a little cutesy, and we can change the color here. So for actors, blue, and for actresses, sorry, I'm going to make them pink. Okay, and the labels are appropriate here. They're the same as what we had before. And again, we have an informative title. These are the best actors. These are the age of the best actresses. And now I have a subgroup of our population. So I'm using the lowercase n. There's 88 winners for men, 88 winners for women. Those look good. Let's grab the actors, put them in, and the actresses, copy and paste. I'm going to do wrap text for both of these. A little bit smaller. And this way I can just put them next to each other however I want. Okay, let's just look at the actors first. This distribution looks similar to the whole population. We can describe sort of the spread or where the clustering is happening. So a majority of the male winners are between, this goes up pretty sharply here at 35 and then kind of comes down at 50. Between 35 and 50. That's a little bit different than what we saw in the whole population. Years old. We see it kind of coming down on either side. They're less likely to win if they get younger or older. With the frequency of winning decreasing at either extreme. Oh, want to tell them where to look? Figure 2. Okay, now let's look at the actresses. The distribution here is a little bit different, both from the population and from the male winners. We can see this goes up really sharply. The mode is right at the beginning here. This is people who are 25 and up to, but not including 30 years old. That's where the majority of the female Academy Award winners are. But it just continues to decline as they get older. There's this little peak from 60 to 65. And then we can see some of our outliers over here as well. So let's contrast that with what we've seen in the males. So use language like on the other hand, most of the women win the award at a young age. We say 25 to 30 years old. And the frequency of winning decreases with age. You know, tell them where to look to find that information. See figure 3. We can also comment on these outliers, the ones that aren't fitting that pattern with the decreasing frequency. So there are a handful of outliers over, what is this, 60 years old. And again, that's pulling the mean this way. The outliers are pointing upward as the age is increasing, so that's creating a strong positive skew. Okay, if you saw that, all my changes were saved. Great. The descriptive statistic that we want to use for a continuous variable should include both a measure of tendency and a measure of variability. In this case, I'm going to use mean and the standard deviation. Excel can calculate that for me, and I'll write a sentence about it in my write-up. You guys calculated this in the tutorial already. Let's go back up to where we were talking about the whole population. Mean age at award for all award winners is 40 and a half years old. And we're going to include the standard deviation here. Was 1108. Again, I'm using my 2 decimal places APA format. Okay, and let's write a sentence about the men and women individually. So when calculating the average, you can use average or mean, age for each gender, we find that women win at a younger age than men. So what were our actual numbers? It's about a 10-year difference, let's say that. By about 10 years. I do want to report the actual descriptive statistics, mean and standard deviation here. So find that women win at a younger age. That mean is, what do we say, 36.84, and the standard deviation of 11.80. And again, for the men as well, mean 44.43, standard deviation of 8.85. Okay, now I can go back and add some extra details, clean it up a little bit. Let's add some information about what we're looking at. So just some context for this data. There have been 88 Academy Award ceremonies, and there's an equal number of males and females. So each year, 1 man and 1 woman are given the award for Best Actor and Best I should put in the group size. Again, capital N, because this is all of the winners that we're looking at here. We can also add some other detail. We can look at who is the oldest person and who is the youngest person to ever have won one of these awards. I've already sorted these data by age. So the youngest winner is Marlee Matlin, who I have not heard of, but we will still acknowledge her for her accomplishments. The youngest winner is Marlee Matlin at 21 years old, while the oldest winner is, let's go find out. Let's see, so this is organized by gender still. The oldest female is Jessica Tandy at 80 years old, and looks like she beat Henry Fonda, so Jessica Tandy is still the oldest winner. Oldest winner is Jessica Tandy, who won when she was just over 80 years old. Okay. Let's clean this up a little bit. Finally, I want to add a conclusion that summarizes our findings. The coolest thing to note is the difference between genders that we saw, and just the shape of these distributions and what that means for winners of the Academy Award. So in conclusion, it appears that the distributions of age in Academy Award winners is not the same for men and women. So let's describe just in our own words what that looks like. Women are more likely to win when they are young. We can see up here. While men have a wider range of winners in middle age. Just the width of this all clustered there. I think that sums it up nicely, and that's really the main point that we might want to make with this data. Again, I can try to make this a little nicer looking, easy for my reader to look at visually. All that fits nicely on one page. I still have my figure labels and names. I think that's good.